where human knowledge meets the boundaries of the unknown, few events shake our understanding of the cosmos more than a cryptic signal from beyond. When NASA's Voyager 1, the farthest-reaching human-made object, sent back an inexplicable message, it ignited global curiosity and concern. But when someone like Elon Musk, a man known for pushing the boundaries of space exploration, technology, and the future of humanity, takes an interest in this message, the stakes are amplified. Musk's fascination with space, alongside his revolutionary work with SpaceX, Neuralink, and Tesla, has long captivated the world. But his reaction to Voyager 1's mysterious transmission takes things to another level. But what could this signal mean? Could it be evidence of an unknown force lurking in the depths of space? Join us as we explore the terrifying possibilities and Musk's role in understanding this galactic enigma. Let's start with a quick look at the grand journey of Voyager 1. The spacecraft was launched on September 5, 1977, just 16 days after its twin, Voyager 2. Both spacecraft were part of an ambitious plan to take advantage of a rare planetary alignment that occurs only once every 176 years. This alignment allowed the spacecraft to use gravity assists from the outer planets to accelerate their journeys, enabling them to visit Jupiter and Saturn without the need for excessive fuel. Voyager 1's primary mission was to explore these two gas giants, with a particular focus on studying their atmospheres, magnetic fields, and moons. Its journey to Jupiter took just under 2 years, and in 1979, Voyager 1 became the first spacecraft to provide detailed images and data of Jupiter's turbulent atmosphere, its Great Red Spot, and its 4 largest moons, Io, Europa, Ganymede, and Callisto. Voyager 1's flyby of Jupiter revealed extraordinary features that had never been observed before. One of the most dramatic discoveries was the detailed study of the volcanic activity on Io, one of Jupiter's moons. Voyager 1 found that Io is the most volcanically active body in the solar system, with hundreds of active volcanoes ejecting sulfur and molten rock far into space. This was the first time active volcanoes had been observed outside of Earth, reshaping our understanding of geological processes in the solar system. Another fascinating discovery came from its observations of Europa, one of Jupiter's icy moons. Voyager 1's images showed that Europa's surface was covered with a layer of ice, leading scientists to speculate that there might be a subsurface ocean beneath. This speculation has continued to grow in recent years, making Europa a prime candidate for future missions to search for potential life in the solar system. After its successful flyby of Jupiter, Voyager 1 continued on to Saturn, reaching the ringed planet in 1980. Once again, the spacecraft provided groundbreaking data and stunning images. Voyager 1's cameras revealed intricate details of Saturn's rings, showing that they were made up of countless individual particles ranging in size from tiny ice grains to massive chunks of rock and ice. It also discovered new, thin rings and mysterious gaps in the rings that continue to intrigue scientists today. Perhaps the most significant discovery from the Saturn flyby came from Voyager 1's close encounter with Titan, Saturn's largest moon. Titan's dense, nitrogen-rich atmosphere made it difficult to observe from Earth, but Voyager 1 revealed that the moon had a thick layer of orange smog that concealed its surface. Titan's atmosphere, made mostly of nitrogen with traces of methane, is unique in the solar system, and it remains one of the most Earth-like atmospheres ever observed on another celestial body. Voyager 1's observations of Titan have since made it a target for future missions, including NASA's upcoming Dragonfly mission, which aims to explore its surface in the 2030s. Although Voyager 1 was originally designed to continue its journey to Uranus and Neptune after Saturn, mission planners decided to send it on a different trajectory after its encounter with Titan. Instead of heading deeper into the outer solar system, Voyager 1 was directed on a course that would eventually take it out of the solar system and into interstellar space. This decision marked the beginning of Voyager 1's next phase, its long journey toward the unknown. Voyager 2, its twin, would go on to complete the grand tour of the outer planets, visiting Uranus and Neptune, while Voyager 1's new mission became the exploration of the farthest reaches of the solar system. Thus, after its flyby of Saturn, Voyager 1 traveled through the outer reaches of the solar system for more than 3 decades. During this time, it passed beyond the orbits of the outer planets and entered the region known as the heliosphere, a bubble of charged particles and magnetic fields created by the solar wind that surrounds the solar system. In 2012, after more than 35 years in space, Voyager 1 made history once again by crossing the heliopause, the boundary where the solar wind is overtaken by the pressure of interstellar space. This marked Voyager 1's official entry into interstellar space, making it the first human-made object to leave the solar system. The spacecraft is now traveling through the interstellar medium, the vast, empty region between the stars. Voyager 1's journey into interstellar space has provided scientists with invaluable data about this little understood region. One of its key discoveries came from measuring the density of particles in interstellar space. Voyager 1 found that the particle density in interstellar space was higher than expected, a discovery that has raised new questions about the structure and behavior of the interstellar medium. Another surprising find was the detection of a constant hum of plasma waves in interstellar space. These plasma waves are created by the interaction between charged particles and the magnetic field of the interstellar medium. This discovery has helped scientists better understand the environment beyond the solar system and how the solar wind interacts with interstellar space. By now, more than 47 years in space, more than 14 billion miles from Earth, our aging hero has continued to transmit data, providing humanity with a rare glimpse into the cosmic wilderness. Despite its distance, the spacecraft's signal still reaches Earth, though faint and delayed due to its vast separation. While NASA expected Voyager 1 to eventually succumb to the ravages of time and space, they didn't expect what happened next. Since 2022, scientists reported receiving a signal from Voyager 1 that didn't match any expected data. It was puzzling, and its implications were unclear. Could it be that Voyager 1 had encountered something entirely foreign, a force or phenomenon we've never seen before? Most likely. Either way, the signal that Voyager 1 sent back was too weird. It didn't fit with the regular patterns NASA had come to expect from the spacecraft. While it continued to communicate, some of the data seemed scrambled or inconsistent with previous transmissions. The spacecraft's instruments, which had operated smoothly for decades, now appeared to be picking up something unusual. This anomaly left experts scratching their heads. Naturally, the initial reaction was to blame the aging systems aboard Voyager 1. After all, the probe had been operating for over 45 years, far exceeding its original mission time frame. Perhaps the instruments had simply degraded, leading to confusing data. However, NASA engineers and space enthusiasts were hesitant to accept this as the full explanation. There was a growing sense that something more mysterious was at play. At the heart of this puzzle was the possibility that Voyager 1 had encountered a previously unknown force in the depths of interstellar space. The spacecraft was in a region beyond the influence of the sun's magnetic field, a place where human understanding is limited. Could there be an unseen energy or force affecting the craft? The idea seemed far-fetched, but it was not impossible. Elon Musk, who has a long-standing passion for space exploration and a deep fascination with the unknown, took notice of Voyager 1's strange message. Musk is no stranger to groundbreaking projects. Through SpaceX, he has revolutionized space travel, bringing humanity closer to making interplanetary life a reality. His efforts to colonize Mars, his dreams of building a sustainable future through Tesla, and his exploration of artificial intelligence via Neuralink make him a visionary, someone always looking beyond the present to what might be possible. When asked about Voyager 1's signal, Musk expressed both intrigue and caution. In the words of Musk, "There's so much we don't know about space. Voyager 1 is in a part of space we've never been. It's possible there's something there we haven't accounted for, something we don't understand yet." For SpaceX's CEO, the mystery of Voyager 1 represented an opportunity to rethink what we know about the universe. As someone who thrives on solving the unsolvable, Musk's involvement in the investigation of this strange signal sparked even greater interest in the event. Musk himself has often spoken about his belief in the possibility of extraterrestrial life, or at least the presence of unknown phenomena in the universe. "The universe is vast, and we've only scratched the surface of what's out there," he has said on multiple occasions. His reaction to the Voyager 1 signal aligns with his broader philosophy of exploring the unexplored, pushing beyond the boundaries of conventional science to seek answers in the stars. Otherwise, the fact that the idea of an unknown force in space is not new. Scientists have long speculated about phenomena that we have yet to detect or fully understand. Dark matter and dark energy, for instance, are theoretical constructs used to explain certain gravitational effects that can't be accounted for by observable matter alone. These forces, which make up the vast majority of the universe, are still largely a mystery to us. Could Voyager 1's signal provide a clue to understanding these forces, or is it detecting something entirely different? One possibility is that Voyager 1 has encountered a region of space dominated by an unknown form of energy. Interstellar space is not entirely empty. It is filled with a thin plasma of charged particles. However, there may be other, less understood forces at play. Some theorists have suggested that there could be cosmic anomalies or energy fields that exist outside our current understanding of physics. Could Voyager 1 have stumbled upon one of these? Another intriguing theory is that Voyager 1 has crossed paths with some form of extraterrestrial technology or civilization. This idea, though speculative, has gained traction among those who believe that humanity is not alone in the universe. Over the years, there have been numerous reports of unexplained signals and anomalies in space, from the famous WOW signal detected in 1977 to the recent discovery of fast radio bursts, FRBs, powerful radio pulses of unknown origin that have been detected from deep space. Could Voyager 1 be experiencing something similar? Perhaps. But to understand how Voyager 1 might encounter extraterrestrial technology, it's essential to examine the concepts of Bracewell probes and von Neumann probes, two theoretical types of alien devices that could be present in interstellar space. First proposed by Ronald Bracewell in 1960, a Bracewell probe is a hypothetical autonomous spacecraft sent by an advanced civilization to search for and communicate with other intelligent life forms. Unlike typical radio or optical signals, these probes would actively travel through space, seeking out signs of intelligent life and engaging in two-way communication. A Bracewell probe could potentially lie dormant, awaiting the arrival of an object like Voyager 1 before activating and initiating contact. This type of probe would make for an ideal explanation of the anomalous data, as it may be trying to communicate with the spacecraft. Such probes would be designed to operate for thousands or even millions of years, ensuring they could encounter and observe developing civilizations. If a Bracewell probe is out there, Voyager 1 might have crossed its path, triggering the strange transmission. Another fascinating concept is the idea of von Neumann probes, named after mathematician John von Neumann. These theoretical devices would be self-replicating probes that an advanced civilization could send out into the galaxy to explore and monitor the universe. Von Neumann probes could harvest raw materials from planets or asteroids, constructing copies of themselves to continue the mission. Because these probes are self-replicating, they could spread rapidly across vast regions of space, potentially increasing the likelihood that Voyager 1 might have encountered one. If a von Neumann probe detected Voyager 1, it might attempt to study or interact with it, possibly explaining the unusual data. And if extraterrestrial probes exist, it's conceivable that Voyager 1 might have triggered a response. The spacecraft carries the famous Golden Record, a time capsule containing sounds and images from Earth, meant to communicate the diversity of life and culture on our planet. The record includes greetings in 55 languages, music from various cultures, and scientific information, all intended to give any intelligent life that finds it a glimpse into humanity's existence. One intriguing possibility is that the transmission issues from Voyager 1 are the result of an attempt by alien technology to communicate back. If an advanced extraterrestrial probe or civilization intercepted Voyager 1, they might be analyzing the data encoded in the Golden Record, trying to understand the origin and purpose of the spacecraft. Alternatively, the strange signal, could be an attempt by extraterrestrial technology to send a message of its own. If so, interpreting this signal would represent an unprecedented challenge for humanity, as we have no established protocol or method for decoding alien communications. The scientific community would need to develop new techniques and approaches to analyze and interpret the data, a task that could take years or even decades. While the idea of Voyager 1 encountering extraterrestrial technology is thrilling, it's essential to approach such a theory with a healthy dose of skepticism. For now, there is no direct evidence to suggest that Voyager 1 has encountered alien technology. Most scientists believe that the strange signals are more likely the result of a technical malfunction or data corruption within the spacecraft's systems. Voyager 1 is operating in a harsh environment, billions of miles from Earth, where radiation, cosmic rays, and the vacuum of space can all contribute to wear and tear on the spacecraft's systems. Given the spacecraft's age, the most straightforward explanation is that its instruments are beginning to fail, leading to the anomalies in its transmissions. However, this explanation does not rule out the possibility of an extraterrestrial encounter. While technical issues remain the leading theory, the sheer remoteness of Voyager 1's location and the unexplored nature of interstellar space leave the door open for more exotic explanations. And for SpaceX and Tesla CEO Elon Musk, who has publicly expressed interest in the potential for extraterrestrial encounters, the unexplained signal from Voyager 1 represents more than just a technical glitch or a scientific anomaly. It's a call to action. He has spoken about the need to investigate the unknown and push humanity's reach further into the cosmos. "We need to be a spacefaring civilization," Musk often says, underscoring his belief that humanity's future lies beyond Earth. One of Musk's proposed solutions is to send a new mission to investigate the region of space where Voyager 1 is currently located. While this would be a monumental challenge, Musk's SpaceX has already demonstrated the ability to achieve what was once considered impossible. A new, more advanced spacecraft could be equipped with state-of-the-art instruments to better understand what Voyager 1 has encountered. Such a mission could revolutionize our understanding of interstellar space and potentially answer questions about the mysterious signal. In addition to sending a spacecraft, Musk has also advocated for the development of more advanced communication systems capable of deciphering complex signals from space. Neuralink, Musk's brain-machine interface company, could play a role in this effort. Musk envisions a future where humans could interface directly with machines to process large amounts of data, potentially making it easier to analyze signals like the one from Voyager 1. The Voyager 1 signal has reignited interest in the unknown aspects of space exploration. As scientists and engineers work to decipher the strange data, the world looks to visionaries like Elon Musk for guidance on what might come next. Musk's willingness to explore new frontiers, both on Earth and in space, makes him uniquely positioned to lead the charge in understanding the mysteries of the cosmos. In the years to come, we may discover that the signal from Voyager 1 was merely a technical hiccup or a product of the spacecraft's aging systems. However, if it turns out to be evidence of an unknown force, it could fundamentally alter our understanding of the universe. Whether this force is a natural phenomenon, an alien technology, or something entirely different, one thing is clear: humanity is on the brink of a new era of discovery. For Musk, this moment represents an opportunity to push the boundaries of what's possible. "The universe is a pretty big place," he often says. "If we don't find out what's out there, we're missing the greatest adventure of all." As Voyager 1 continues its journey into the unknown, the mystery of its signal serves as a reminder that the universe is full of surprises and that our greatest discoveries may still lie ahead. In conclusion, Elon Musk's reaction to the Voyager 1 signal encapsulates his broader philosophy about space exploration and the unknown. For Musk, space is not just the final frontier. It's the key to humanity's future. Whether or not Voyager 1 has encountered an unknown force in space remains to be seen, but one thing is certain: Musk's determination to explore the cosmos ensures that humanity will continue to seek answers to the universe's greatest mysteries. And as we push deeper into the stars, we may finally discover what lies beyond. Notably, scientific community recently has focused on dark matter, one of the most mysterious substances in the universe, outmassing normal matter by a 5.1 margin, but showing no evidence of interacting otherwise, either with normal matter or itself. To date, there are a great many direct detection efforts underway, but all have proven fruitless so far, including nuclear recoil experiments and annihilation experiments, yielding only limits on dark matter's properties. Many will not be convinced of dark matter's existence unless direct detection efforts succeed, but there's no guarantee that our current approaches will ever reveal it. What if dark matter is truly collisionless? It's a great and troubling question, and one we must reckon with very seriously. Here's what the science has to say about it. Observationally, there's an overwhelming amount of evidence that indicates the presence of a species of energy that has existed from very early times in the universe's history that gravitates like the matter we're familiar with does, but that shows no evidence for interacting in any other way, either with itself or with any of the known particles of the Standard Model. We see evidence for the presence of this unfamiliar material, which serves as a source of gravity, across a wide variety of cosmic probes. It shows up when we weigh individual galaxies, when we weigh pairs of galaxies that are interacting, when we measure the gravitational lensing effects of galaxies, galaxy groups, or clusters of galaxies, when we tally up the total amount of normal matter in stars, gas, dust, plasma, and black holes, and compare it with the total mass that we see in a variety of cosmic objects, when we examine the pattern of fluctuations present in the CMB, the leftover glow from the Big Bang, when we examine the clustering patterns imprinted in the cosmic web, and when we measure a feature known as baryon acoustic oscillations, imprinted in galaxy-galaxy correlations across hundreds of millions of light years. All of these independently measurable lines of evidence indicate that the normal matter we see is wholly insufficient to explain the universe we observe on its own. Something else, in addition, must be present. Another strong, but often overlooked piece of evidence is shown above. The abundance of the light elements and isotopes, which were forged long before the first star in the universe ever ignited. Early on, in the crucible of the Big Bang, temperatures were high enough and densities were great enough that nuclear reactions could proceed, where protons and neutrons would undergo fusion reactions, creating a variety of light elements and their isotopes in some non-negligible abundance. This included the forging of deuterium, 1 proton and 1 neutron, tritium, 1 proton and 2 neutrons, which will decay to helium-3, helium-3, 2 protons and 1 neutron, helium-4, 2 protons and 2 neutrons, lithium-7, 3 protons and 4 neutrons, beryllium-7, 4 protons and 3 neutrons, which will decay to lithium-7, and tiny amounts of even heavier elements, like beryllium-9 and beyond. The nuclear physics that took place in the very early universe, known today as Big Bang nucleosynthesis, is extraordinary because all of the reactions that occur, leaving behind a specific abundance of these various elements and isotopes relative to one another, is dependent only on one cosmological parameter, the baryon to photon ratio. We've since measured that value exquisitely and found that it's about 6 times 10 to the power of -10, meaning there's about 1 baryon for every 1.7 billion photons in the universe. That corresponds to a matter density that's about 5% of the overall density of the universe. But measurements of the total amount of matter in the universe, from galaxy clusters and gravitational lensing observations, for instance, reveal a figure that's more like 30% of the universe's total energy density. All of these lines of evidence, when put together, clearly indicate the presence of some type of mass in the universe that isn't part of our standard model. Moreover, that mass has to have specific properties that are highly constrained by cosmic observables. It must have existed from very early times, as its signals are thoroughly imprinted in the CMB, which was emitted just 380,000 years after the Big Bang. It must have been moving slowly compared to the speed of light, or must have been what cosmologists call cold, even from the moment of its birth, implying that it was either created non-relativistically, or if it was created thermally, it was heavy enough that at no point in cosmic history was it moving fast relative to the speed of light. It must not have annihilated away with itself, must not have clumped together like normal matter does, and must not have interacted electromagnetically through the strong force, or through the weak interactions in any appreciable, measurable way, even from early times. For these reasons, what was originally referred to as the missing mass problem became known as the dark matter problem, as it appeared that the universe must contain some type of massive species of energy that gravitates, but that doesn't emit or absorb light, and doesn't interact or collide with normal matter or itself in any detectable way. Beginning in the mid-2000s, we started to even detect clear signatures that some type of massive signature must be present within galaxies and galaxy clusters. As colliding systems began to reveal a clear separation between the normal matter, which heats up and emits X-rays, and the total mass, which is revealed from gravitational lensing signals. The evidence from the full suite of evidence strongly indicates the presence of a massive new species of energy, which experiences the force of gravity and clumps together on cosmic scales, but which doesn't splat together, interact with light, or make bound structures with either normal matter or itself in any discernible way. So what could this dark matter be, and how could we detect it? There are two main ideas that have been pursued since the latter half of the 20th century. Dark matter could be WIMP-like, meaning that there could have been a massive, heavy particle beyond the standard model that was once produced, in great abundances, in the early stages of the hot Big Bang. As the universe cooled, some species of massive relic particles persisted, moving slowly compared to the speed of light, and it still persists today. Although rare, interactions and collisions with standard model particles could still occur, since that's how these particles, at very high energies, were created in the first place. Dark matter could also be axion-like, in the sense that it could be made of particles, of any mass, not just heavy ones, that were pulled out of the quantum vacuum during a phase transition in the early universe, but that were born cold, with practically no kinetic energy at all. The hypothesized Pecky-Quinn symmetry and the breaking of that symmetry was the origin of the axions as dark matter idea and of this mechanism. Even though that idea in its original incarnation has now been ruled out, the search for axions and axion-like particles continues. The way you search for WIMP-like particles is to build experiments that look for nuclear recoils, as there should be some non-zero cross-section, at least at some high energy, and presumably at lower energies too, between whatever dark matter is and at least one of the standard model particles. Complementarily, the way you search for axion-like particles is to build an electromagnetic cavity that's capable of exploiting a theoretical coupling between axions, or axion-like particles, and photons. At low temperatures and when tuned to specific frequencies, any dark matter particles that happen to be passing through the detectors, dependent on their mass and cross-section, could be converted into photons, and detecting those photons would then be a telltale signature of dark matter. But here's the thing. Dark matter doesn't have to be a thermal relic that arose from interactions with standard model particles, and it doesn't have to be a pulled from the vacuum relic that will couple to the photon, or any other standard model particle. It could be a heavy, exotic, right-handed neutrino that was created at the start of the hot Big Bang and never interacts with anything in the standard model. An ultra-heavy WIMPzilla particle that was created early on through purely gravitational processes and will never interact with any standard model particle through any force or something more general that arose from a severely out-of-equilibrium condition, which wouldn't necessarily interact with any of the standard model particles or fields through the strong electromagnetic or weak interactions. If any of these are the case, then all our current classes of experiment will do is continue to push down, to lower and lower boundaries, the cross-section of whatever dark matter is in a certain mass range below a certain limit. This is an incredible feat of experimental physics, but it isn't ever going to reveal dark matter's nature directly, if this is the case. A lot of people think that because we talk about dark matter as possibly being made up of WIMPs, where WIMP stands for weakly interacting massive particle, that we fully expect it to interact through the weak interaction. This is not true. There is a scenario known as the WIMP miracle, where if you make a thermal relic in, say, supersymmetric or similar scenarios, The cross-section you need to produce the right abundance of massive particles to match observations just happens to match the predicted cross-sections that would proceed through the weak interactions. However, as LHC data is more and more convincingly showing, the parameter space for the WIMP miracle scenario is almost entirely excluded. The WIMP miracle, except among the most fervent supersymmetry believers, is almost totally dead. Instead, it's worth recognizing that what we would have once considered a nightmare scenario for dark matter, the possibility that it has no interactions to observe other than gravitational ones, might in fact be the scenario that nature has presented us with. The theoretical motivation for completely collisionless dark matter is very strong, as there are no signals indicating collisions with atomic nuclei, no signals indicating conversion to photons, and no signals indicating a self-interaction or self-annihilation cross-section, and yet, the observational evidence indicating dark matter's presence is overwhelming. This is not a flaw or a fault in our techniques. This is a limitation imposed by what the universe gives us to work with. It is only normal standard model particles that we know how to interact with. If we think more generically, any species of energy that strikes a particle, a quark, a gluon, an electron, etc., is going to impart energy and momentum to it whenever it occurs. We can build enormous detectors around collections of matter, things made of quarks, gluons, and electrons, and look for any of the downstream signatures that are generated by such a collision. The goal shouldn't be to find dark matter, as that's assuming we know what nature is up to, and that is not a thing we're able to know until we find out. The goal should be to interrogate nature as comprehensively as possible and to put as many well-motivated or even not ruled out scenarios to the critical test as possible. The push to make experiments that take larger, more pristine samples of material and observe them for longer periods of time, with well-accounted-for backgrounds and ever tinier uncertainties and errors, is literally the best we can do with the universe we have. Anyway, science is a cumulative endeavor, and every step we take along the path has valuable lessons to teach us. If only we're willing to learn from what nature reveals about itself.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Let's discover something new today. Here's something that we have limited understanding of. Let's improve on that.
In the vast, dark expanses of space, where human presence has barely scratched the surface, NASA's Voyager 1, the farthest human-made object from Earth, continues its extraordinary journey into the unknown. And now, in a twist that could only be described as the stuff of science fiction, a recent development has sent shockwaves through the scientific community. Voyager 1 has received an alarming signal, an unexpected reply, from what appears to be a nearby object in space. But how? What could be nearby in such a remote part of space? If so, what exactly was it? All this and more will be discussed in today's episode. Before delving into this unprecedented event, it is essential to understand the context of the Voyager mission. In the 1960s and 1970s, planetary science was in its infancy. The Mariner missions had flown by Venus and Mars, providing humanity's first close-up images of other planets. Yet the outer planets, gas giants like Jupiter and Saturn, and the more distant Uranus and Neptune, remained mysterious. No spacecraft had yet visited these worlds. NASA was eager to change that, but the challenge was formidable. The distances involved in reaching the outer solar system were enormous, far exceeding those of the inner planets. The timing for such a mission was fortuitous. In the late 1970s and early 1980s, a rare planetary alignment of the outer planets presented a unique opportunity. This alignment, occurring once every 176 years, would allow a spacecraft to use gravitational assists from one planet to slingshot toward the next, significantly reducing the time and energy required to visit all 4 outer planets. Known as the Grand Tour, this alignment enabled a single mission to explore Jupiter, Saturn, Uranus, and Neptune. The Voyager mission was designed to capitalize on this rare window. Initially, the Voyager mission had more modest objectives. NASA planned to send the spacecraft to study the atmospheres, moons, and magnetospheres of Jupiter and Saturn. There was no guarantee that Voyager 2 would be able to continue to Uranus and Neptune. The spacecraft would have to survive the rigors of deep space and function long enough to send back useful data. However, the Grand Tour alignment meant that a mission designed to study just 2 planets could potentially visit all 4, given the right circumstances. Otherwise, the Voyager spacecraft themselves were designed to be highly autonomous, a necessity given the vast distances over which they would operate. Communication with Earth, even at the speed of light, could take over 20 hours by the time the spacecraft reached the outer planets. As a result, the spacecraft had to be able to manage their scientific instruments, detect malfunctions, and conduct experiments without waiting for instructions from mission control. Voyager's communication system was particularly advanced for its time. Each spacecraft was equipped with a high-gain antenna to send data back to Earth via radio signals. The data rate slowed as the distance from Earth increased, but the Deep Space Network, a global system of antennas designed to communicate with spacecraft, was able to pick up even the faintest signals from the distant Voyagers. The spacecraft carried a suite of scientific instruments, including cameras, magnetometers, plasma detectors, and infrared and ultraviolet sensors. These instruments were designed to operate in the extreme cold and darkness of the outer solar system, allowing the Voyagers to make discoveries that fundamentally altered our understanding of the outer solar system. The spacecraft's flybys of Jupiter and Saturn yielded a wealth of data and revealed unexpected phenomena. For instance, Voyager 1 discovered active volcanoes on Io, which was a major surprise to scientists who had not expected such geologic activity on a moon so far from the Sun. The mission also revealed the complexity of Jupiter's atmosphere with its colorful bands, storm systems, and massive Great Red Spot, a storm larger than Earth. At Saturn, Voyager discovered intricate details of the planet's ring system, including the existence of small moonlets that help shape the rings through their gravitational influence. Voyager also provided detailed images of Saturn's moon Titan, which appeared to have a thick atmosphere, raising questions about its potential for hosting chemical processes similar to those that might have led to life on Earth. Voyager 2's extended mission took it to Uranus and Neptune, making it the only spacecraft to have visited these 2 distant planets. At Uranus, Voyager 2 discovered that the planet's magnetic field was tilted dramatically from its rotational axis, suggesting a highly unusual interior structure. The mission also provided the first close-up images of Uranus's moons, revealing that the moon Miranda had a surface scarred by massive canyons and strange terrain. At Neptune, Voyager 2 discovered that the planet, despite being so far from the Sun, had active weather systems, including the fastest winds in the solar system. The spacecraft also discovered geysers on Neptune's moon Triton, indicating that the moon was geologically active despite its extreme cold. After completing their planetary flybys, the Voyager spacecraft were tasked with an even more ambitious goal: exploring the boundaries of the solar system and entering interstellar space. In 2012, Voyager 1 became the first human-made object to enter interstellar space, passing beyond the influence of the Sun's magnetic field. Voyager 2 followed in 2018. These milestones marked the beginning of the Voyager interstellar mission, during which the spacecraft continued to send back data about the environment of interstellar space, including measurements of cosmic rays and the density of particles in the interstellar medium. And now, after over 40 years from its launch, the twins continue to send back data through the Deep Space Network, providing scientists with critical insights into a region of space that had never before been directly explored. And to keep the aging heroes, NASA itself continues to monitor it regularly, checking its health and ensuring it continues to function. However, recently, in one such routine check-in, something strange happened. the data transmitted back from Voyager 1 was different. Embedded within the usual streams of cosmic ray measurements and particle density data was an anomaly. Initially, the mission control team thought it was an error, a malfunction in the aging spacecraft's instruments. After all, Voyager 1 is over 14 billion miles from Earth, and its systems are long past their intended lifespans. However, after further analysis, the team discovered that the signal wasn't random noise. It appeared to be structured, almost as if it were a form of communication. As scientists pored over the data, they made a startling realization. The signal didn't originate from Voyager 1 itself, but seemed to have been received from something in close proximity to the spacecraft. Voyager 1, traveling at nearly 38,000 miles per hour, was in a part of space thought to be almost entirely empty, save for the thin smattering of cosmic dust and charged particles. The idea that another object could be near Voyager 1, let alone capable of sending a signal, was both exciting and unnerving. The signal, when decoded, exhibited a pattern that defied natural cosmic phenomena like pulsars or black hole emissions. It seemed deliberate. But what could be nearby in such a remote part of space? Theories began to swirl. Some speculated it could be a reflection of Voyager's own transmissions, bouncing off some unknown interstellar medium. Others wondered if it could be an alien probe, or perhaps even something more enigmatic, a relic from a long-lost interstellar civilization. The anomaly forced scientists to revisit the data Voyager 1 had been sending back for years. In doing so, they uncovered faint indications of something unusual. In its telemetry, there were previously overlooked fluctuations in the magnetic fields and plasma density readings. These fluctuations were subtle but consistent, suggesting that Voyager 1 might have been passing through or near some sort of cosmic structure, a dust cloud, an asteroid, or even something entirely unknown. The key question was, could this object have sent the signal? Was it nearby? If so, what exactly was it? NASA's Jet Propulsion Laboratory, also known as JPL, which manages the Voyager mission, has been cautious about jumping to conclusions. However, several independent scientists, analyzing the public data, have suggested that this object may not be a natural phenomenon at all. In fact, based on Voyager 1's current location, beyond the Oort cloud in interstellar space, this object's existence is baffling. It's a region where traditional astrophysical models predict there should be almost nothing. So, the mere presence of something capable of sending a coherent signal could upend our understanding of the composition of deep space. Theories about the source of the signal have grown more complex and intriguing. One of the more conventional explanations is that Voyager 1 might have stumbled upon an unknown type of interstellar object, something akin to Oumuamua, the mysterious elongated interstellar object that passed through the solar system in 2017. However, Oumuamua was a passive object. It did not emit any signals. Could this new object be another visitor from outside the solar system, but far more advanced or active? Another possibility is that the object could be a fragment of a comet or asteroid dislodged from the Oort cloud and somehow interacting with the spacecraft. However, the likelihood of a random space rock sending a structured signal seems slim. Furthermore, the energy required for such a transmission would be immense, far beyond what any known natural object could produce. Then, of course, there's the more provocative idea. The signal might have been sent intentionally by an intelligent entity. This notion, while far-fetched, is not entirely without precedent. In recent years, astronomers have detected a variety of strange signals from space, including fast radio bursts and long-duration radio waves. Some have speculated that these phenomena could be artificial, though there is no conclusive evidence to support that theory. If the signal were indeed from an extraterrestrial source, it would raise profound questions about its nature. Why is it replying to Voyager 1, And how did it detect the spacecraft in the first place? Given that Voyager 1 carries a golden record, an encoded message to any potential alien civilization that might encounter it, could this signal be a response to that message? The golden record contains images, sounds, and greetings in 55 languages, along with scientific data about Earth. It was intended as a time capsule of humanity, a symbolic gesture meant for any intelligent beings Voyager might meet on its journey. Could it be that, after 4 decades, someone, or something, has finally found it? While it is still too early to determine the nature of the signal with certainty, the mere possibility of extraterrestrial communication has reignited public fascination with the Voyager mission. The event has also raised broader questions about our place in the universe. If we are not alone, what are the intentions of those who might be listening? Are they friendly, curious, or something else entirely? At the same time, scientists are acutely aware of the potential risks of making contact with an unknown entity. The famous physicist Stephen Hawking once warned that broadcasting our presence to the cosmos could be dangerous. He suggested that if an advanced civilization were to detect our signals, their intentions might not be benign. After all, human history is filled with examples of more technologically advanced civilizations conquering less advanced ones. NASA has remained tight-lipped about its next steps, citing the need for more data before making any definitive statements. However, the space agency has ramped up its monitoring of Voyager 1 and the surrounding region. They are currently working on new algorithms to analyze the signal in greater detail, hoping to decipher its origin and meaning. Meanwhile, the scientific community is abuzz with speculation. Some researchers have proposed sending a follow-up probe to investigate the region of space where Voyager 1 received the signal. Others are advocating for more radio telescopes to be trained on the spacecraft's current location, searching for further clues. In the coming months, as more data is collected and analyzed, the world may finally learn the truth about this mysterious signal. Whether it's a natural phenomenon, an interstellar object, or something more extraordinary, the event has already earned its place in the annals of space exploration history. Voyager 1, humanity's tireless emissary to the stars, may have stumbled upon a discovery far more significant than any we could have ever imagined. And to do this, NASA have to keep the probe alive. One of the most critical aspects of keeping Voyager 1 alive is managing its power supply. Unlike spacecraft that rely on solar panels for energy, Voyager 1 uses 3 radioisotope thermoelectric generators, or known as RTGs, which convert the heat generated by the radioactive decay of plutonium-238 into electricity. These RTGs were designed to power the spacecraft for many years, but even their output decreases over time as the plutonium decays. At launch, Voyager 1's RTGs provided about 470 watts of electrical power. However, after more than 4 decades, the power output has diminished significantly, reducing by about 4 watts per year. By 2024, the available power had dropped to around 240 watts, just over half of what it had originally. NASA knew that power would eventually become a limiting factor, so engineers had to come up with ways to manage this diminishing energy supply while maximizing the spacecraft's capabilities. So, to keep Voyager 1 operational with reduced power, NASA has implemented a series of power-saving strategies over the years. The spacecraft's scientific instruments, heaters, and communication systems all require electricity, but not everything can be powered at once. To conserve power, NASA has gradually turned off some of Voyager 1's scientific instruments. Out of the 11 original instruments, only 4 remain operational. For example, the Plasma Science instrument was turned off in 2007, and others have followed since then. These decisions are made carefully, based on which instruments are most critical to the spacecraft's current scientific mission in interstellar space. Another key power-saving strategy has been to turn off heaters that are no longer needed. Voyager 1 was designed to withstand the cold temperatures of space, but certain instruments require heating to function properly. For example, in 2012, NASA turned off the heater that was keeping the spacecraft's cosmic ray subsystem warm. The instrument continues to function, albeit at much lower temperatures than it was designed for, a testament to the robustness of Voyager's engineering. NASA has had to prioritize the operation of critical systems. The primary goal is to keep the spacecraft's communication systems functional so that it can continue to transmit data back to Earth. The spacecraft's antenna, power supply, and data transmission systems are given priority in power allocation. Another significant challenge in keeping Voyager 1 alive is maintaining communication with the spacecraft. At a distance of more than 15 billion miles, the time delay for signals to travel between Earth and Voyager 1 is over 20 hours. This means that every command sent to the spacecraft takes more than 20 hours to reach it, and it takes just as long to receive a response. The vast distance also means that Voyager 1's radio signals are extremely weak by the time they reach Earth. To communicate with Voyager 1, NASA relies on its deep space network. The DSN is the only system capable of receiving the faint signals from Voyager 1 and sending commands to the spacecraft. Engineers have upgraded the DSN over the years to ensure it remains capable of picking up the weak signals, which are now many times fainter than the original signal strength due to the distance and reduced power output. One of the most remarkable aspects of the Voyager mission is that NASA has been able to remotely update the spacecraft's software and troubleshoot problems, despite the vast distance. Over the years, the mission team has uploaded new software, reprogrammed systems, and addressed hardware malfunctions, all from billions of miles away. In 2017, NASA reactivated Voyager 1's backup thrusters, which had not been used since 1980. The spacecraft uses small thrusters to orient its antenna toward Earth so that it can communicate. The primary thrusters were degrading, making it difficult for Voyager to stay properly oriented. In response, NASA sent commands to switch to the backup thrusters, and after a 37-year hiatus, they worked perfectly. In another instance, in 2022, Voyager 1 experienced an anomaly in its attitude articulation and control system, or AACS, which was responsible for orienting the spacecraft. The AACS began sending garbled telemetry data back to Earth. Engineers worked for months to diagnose the issue and eventually discovered that the AACS had begun sending data through an onboard computer that had long since stopped working correctly. NASA was able to send commands to switch the system back to the correct computer, restoring proper telemetry. These troubleshooting efforts demonstrate the incredible flexibility of the Voyager spacecraft and the ingenuity of the NASA engineering team. With such limited resources and the long communication delays, every problem-solving effort requires careful planning and creativity. However, the deep space environment is not only cold, but also highly variable. Voyager 1 was designed to withstand the frigid temperatures of space, but its journey into interstellar space has exposed it to even colder conditions than it encountered in the outer solar system. Managing the spacecraft's thermal environment is critical to ensuring its continued operation. Each of Voyager 1's scientific instruments and systems has a minimum operating temperature. If the temperature drops too low, the equipment could malfunction. To manage this, NASA has been selectively turning off heaters to save power, but they must carefully balance this with the need to keep certain systems warm enough to function. As the spacecraft's RTGs continue to produce less and less power, it will become increasingly difficult to keep Voyager 1's systems warm. Eventually, the spacecraft may cool to a point where key systems fail, marking the end of its operational life. However, NASA's engineers are working to push that date as far into the future as possible. Most recently, NASA engineers had to resolve a thruster issue affecting Voyager 1, overcoming a series of obstacles posed by the probe's aging hardware. The wear and tear of space travel has caused Voyager 1's thrusters to become clogged. A fuel tube inside the thrusters has filled up with silicon dioxide, a side effect of age within the spacecraft's fuel tank. To help Voyager 1 continue its mission, a team of engineers switched to a different set of thrusters than the one the spacecraft had been relying on. Plot twist: that one is clogged, too. Voyager 1 uses its thrusters to point itself towards Earth and keep communication lines open with ground control. The spacecraft has 3 sets of thrusters, 2 for attitude propulsion and 1 for trajectory correction maneuvers. During the beginning of its mission, Voyager 1 needed the different types of thrusters to carry out its planetary flybys, but the spacecraft is now on a straightforward path out of the solar system. Therefore, it's no longer picky with which one it uses. In 2002, the mission team at NASA's Jet Propulsion Laboratory noticed some fuel tubes in the attitude propulsion thruster set were starting to clog. The team switched to the second attitude propulsion set, but that one showed signs of clogging in 2018, which prompted the engineers to rely on the trajectory correction thruster set. Over the past 6 years, that thruster became even more clogged than the other 2 when the team made the switch. The opening of the trajectory correction thruster tube was originally 0.01 inches, or 0.25 millimeters, in diameter, and now it's been reduced to 0.0015 inches, or 0.035 millimeters, or about half the width of a human hair, according to NASA. As a result, the team had no choice but to switch back to one of the 2 attitude propulsion thrusters. This procedure of switching thrusters would have been easy back in the day, but Voyager 1 is no spring chicken, and the spacecraft requires more careful handling today. Controllers turned off some unnecessary onboard systems, including some heaters. That strategy successfully reduced the spacecraft's power usage, but it also caused Voyager 1 to become colder. As a result, turning on the unused thrusters risked damaging them, so the team had to warm them up first, using the spacecraft's non-essential heaters. The dilemma continued, as the spacecraft's power supply is now so low that turning on the non-essential heaters would require the mission team to turn off something else. Instead, the engineers figured they could turn off the spacecraft's main heaters for about an hour, just enough time to warm up the thruster. All that effort paid off, and Voyager 1's needed thruster branch was up and running. However, it's clear that the aging interstellar probe requires a lot more to keep up and running. As Suzanne Dodd, Voyager's project manager, said in a statement, "All the decisions we will have to make going forward are going to require a lot more analysis and caution than they once did." Despite NASA's best efforts, there will come a time when Voyager 1 can no longer function. The power from its RTGs will continue to decline, and eventually, there won't be enough electricity to keep the spacecraft's systems operational. Based on current estimates, this could happen sometime in the 2030s. When Voyager 1's power supply finally runs out, it will no longer be able to communicate with Earth. The spacecraft will continue its journey through interstellar space, silently traveling at over 38,000 miles per hour, equals 61,000 kilometers per hour, toward the constellation Ophiuchus. Even after it stops sending data, Voyager 1 will remain a symbol of humanity's curiosity and desire to explore the unknown. The Voyager mission has inspired generations of scientists, engineers, and space enthusiasts. The spacecraft has provided humanity with its first close-up views of the outer planets and their moons, revealing complex and fascinating worlds beyond our own. Its journey into interstellar space marks a new frontier in exploration, where Voyager 1 continues to push the boundaries of human knowledge. NASA's success in keeping Voyager 1 alive for so many decades is a testament to the foresight and ingenuity of the engineers who designed it and the teams who continue to manage it. The spacecraft's longevity and continued contributions to science demonstrate the incredible potential of space exploration, and the enduring importance of curiosity-driven research. As Voyager 1 continues its voyage through the stars, it serves as a reminder of what humans can achieve when we dare to dream and push the limits of technology. Even as it eventually falls silent, its legacy will live on, inspiring future missions that may one day venture even further into the cosmos. In the meantime, let's take a quick look at some recent remarkable discoveries. Astronomers recently spotted a surprising smiley face beaming up from the surface of Mars as they surveyed the alien landscape as part of a new study. The emoticon-like structure, which is only visible under certain conditions, is the remnant of an ancient lake that dried up billions of years ago and could be harboring signs of former life on the red planet. The European Space Agency shared an image of the smiley face in an Instagram post on September 7th. The grinning shape, which is made up of a ring of ancient chloride salt deposits with a pair of meteor crater eyes, was snapped by ESA's ExoMars Trace Gas Orbiter, which has been analyzing the levels of methane and other gases in Mars' wispy atmosphere since 2016. Normally, deposits like this would be indistinguishable from the rest of Mars's surface. But when viewed using infrared cameras, like the ones on the ExoMars orbiter, the salts appear pink or violet. The photo was taken as part of a study, published August 3 in the journal Scientific Data, in which researchers created the first robust catalog of chloride salt deposits on Mars using images from the ExoMars orbiter. In total, the team identified 965 different deposits scattered across the alien world, ranging in size from 1,000 to 10,000 feet, or 300 to 3,000 meters, wide. It is currently unclear how large the smiley face is. These deposits are particularly important because they can provide optimal conditions for biological activity and preservation, which makes them a prime target for astrobiological exploration. Mars was once a watery world, with lakes, rivers, and a shallow ocean similar to those on Earth. But somewhere between 2 billion and 3 billion years ago, the water dried up after severe climate change. This was likely driven by the loss of Mars' magnetic field, which allowed solar wind to gradually scrape away most of the planet's atmosphere and eventually caused most liquid water to freeze or evaporate into space. The salty deposits were left behind as the last water disappeared from Mars' lakes at the end of the planet's dynamic aqueous past. In some locations, the leftover salts are the only evidence that there was any water there at all, they added. But these deposits could also have big implications for the search for evidence of ancient life on Mars. According to a statement from ESA, the researchers believe that as Mars' lakes began to shrink and disappear, the remaining water would have become very salty, allowing it to stay liquid despite temperatures as low as -40 degrees Celsius. These last salty puddles could have become a haven for the microbial extremophiles that may have survived Mars's transformation, causing their remains to accumulate in these deposits as the water finally dried up, the researchers wrote in the statement. If this happened, the salts could also have acted like a preservative, potentially keeping the evidence of these extinct life forms intact for billions of years. Recent major discoveries also hint that Mars currently has much more water than we initially thought, which have re-triggered hopes of finding living microbial Martians on the red planet in the future. In June, astronomers announced the discovery of at least 150,000 tons of water frost on the peaks of some of Mars' tallest volcanoes. And in August, scientists revealed that an enormous hidden ocean, with enough water to cover the planet with 1.6 kilometers of water, could be hiding below the red planet's surface. Besides, we have some incredibly powerful telescopes that have given us spectacular views of the cosmos and allowed us to look back to the early days of the universe. These observatories, such as the James Webb Space Telescope. But what if we could access an even better telescope that already exists? This wouldn't be a typical telescope. It wouldn't even come with a lens. but it would be by far the most powerful telescope we'd ever built. This telescope would use the sun itself. To give some perspective on how powerful a sun-based telescope could be, consider James Webb. With a mirror that's 6.5 meters in diameter, James Webb is capable of achieving a resolution of around 1/10 of an arc-second, which is about 600 times better than the human eye. At that resolution, the telescope could see the details on a coin placed 40 kilometers away from it, or pick up the pattern of a regulation soccer ball sitting 550 kilometers away. While the sun may not look like a traditional lens or mirror, it has a lot of mass. And in Einstein's theory of general relativity, massive objects bend space-time around them. Any light that grazes the surface of the sun gets deflected, and instead of continuing in a straight line, heads toward a focal point, together with all the other light that grazes the sun at the same time. Astronomers already use this effect, called gravitational lensing, to study the most distant galaxies in the universe. When light from those galaxies passes near a giant cluster of galaxies, the mass of that cluster amplifies and magnifies the background image, allowing us to see much farther than we normally could. The solar gravitational lens leads to an almost unbelievably high resolution. It's as if we had a telescope mirror the width of the entire sun. An instrument positioned at the correct focal point would be able to harness the gravitational warping of the sun's gravity to allow us to observe the distant universe with a jaw-dropping resolution of 10 to the power of 10 arc-seconds. That's roughly 1,000,000 times more powerful than the Event Horizon telescope. To say this would be better than any known telescope is an understatement. It would be better than any telescope we could possibly build in any possible future for the next few hundred years. The telescope already exists. We just have to get a camera in the right position. For nearly 5 decades, NASA's Voyager 1 spacecraft has been journeying through the vast expanse of space, becoming the farthest human-made object from Earth. Originally launched on September 5, 1977, the spacecraft's primary mission was to explore the outer planets of the solar system: Jupiter, Saturn, Uranus, and Neptune. Having accomplished that, Voyager 1 has continued its mission, sending back invaluable data from beyond the heliosphere, the protective bubble of charged particles surrounding our solar system. But now, after 47 years in the depths of interstellar space, Voyager 1 has made a new discovery that is raising both awe and concern. Even Bill Nye, known as the Science Guy and a renowned science educator and advocate, has publicly commented on Voyager 1's latest finding, calling it terrifying. This statement has stirred curiosity and alarm across the scientific community and beyond. But what exactly has Voyager 1 discovered that is so unsettling? To understand the gravity of this revelation, we must delve into the mission's history, its journey through the solar system, and the implications of its recent discovery. Before we discuss Voyager 1's startling discovery, it's essential to appreciate the magnitude of its journey. Launched at the height of the space age, Voyager 1's mission was initially designed to last just 4 years. However, thanks to the durability of its systems and the foresight of its creators, it has survived for nearly 5 decades, providing scientists with a treasure trove of data about the outer reaches of our solar system and beyond. Voyager 1's primary accomplishments in the early years of its mission were its close encounters with Jupiter and Saturn. And far exceeding all the expectations, the spacecraft sent back stunning images and data that forever changed our understanding of the outer planets. Voyager 1 captured unprecedented views of Jupiter's Great Red Spot and detailed images of Saturn's intricate ring system. Perhaps one of the most significant discoveries was the detection of